really, we'll start first and foremost by the dang definition. Zero trust feels like a really loosey-goosey sort of term, and it didn't resonate with me at first, at least at face value. So really, we'll look at a few different definitions of it. First is one of my old employers. I used to work at Google, and back then, right after I left, like mid 2000s, they had a really significant breach where some Chinese nationals had taken some serious significant portions of their source code, the AdSense engine, some pretty significant things. From what I understood from a paper that they wrote, it was called Beyond Corp was the name of the paper. It was one of the first really that I saw outside of the military talking about zero trust principles. And the way that they kind of described it in the paper was particularly a little bit more simplistic than the way that NIST and the NSA define it. But connecting from a particular network must not determine which services you can access. And that's a really simplistic statement. But when you think about the implementation of that, there's some hair in those details. So you take the next statement, access to services is granted based on what we know about you and your device. So no longer is it just about authentication and authorization at the user level, but also the device level and its posture is taken into account. And then Google has a little nuance in theirs, and they say that of course it needs to be authenticated, authorized, and they add the encrypted. We kind of feel like that's kind of table stakes. This was the early, again, paper around zero trust from a corporate perspective. If we look at it from the guys who really know, the National Security Agency, their definition has a little bit more detail, a little bit more meat on the bones. So theirs is the security model is a set of system design principles, so a little bit higher level, in a coordinated cybersecurity and system management strategy. So a little bit, again, more around framework on the acknowledgement that threats exist both inside and outside of your traditional network, right? So that those boundaries no longer exist from the NSA's definition of zero trust. And they say that their zero trust model eliminates that implicit trust that you get from being on a specific network or a specific element or a specific service. And they go even a little bit further and say that it instead requires continuous verification of the operational picture via real-time information fed from multiple services. That's a big statement from a security posture perspective, because now you have no implicit trust from a network perimeter or device or a user's perspective. And you're supposed to be taking in their behavioral analytics across all those devices and having that factor in continuously in that authorization decision. That's the way the NSA defines it. Let's look how NIST is really kind of closer to, or maybe in between Google in the way the NSA describe it. They say that zero trust assumes there's no implicit trust granted to assets, kind of in the same way, or user accounts based solely on their physical or network location. So really in line with Google and NSA, or based on ownership. So again, along the NSA, and authentication and authorization, both for subject and device. So again, they keep referencing the device or discrete functions performed before the session is established. And that is a little different from the way the NSA sees it. And when it has architectural knock-on effects, and we'll see that in just a second when we start peeling back the covers. So what the heck does that all mean? Those are some pretty loosey-goosey definitions, but if you try to distill it down, I think John did a great job on this slide. Really, it's kind of four main principles. You don't trust anything, so the implicit trust that you used to have because a device was in a set perimeter or had a set amount of scans on it is no longer the case. To validate that, you got to log everything. So not only host level and is my antivirus active, filtering, and coming back as compliant, but also what is going through the authorization process? What are the things that the user is actually doing once they're granted authorization? And are those things anomalous? And if so, you need to assume compromise continuously through that authenticate or authorization or authenticated session, and assume compromise could happen at any point and be able to trigger and close that session when you see that activity. So those
And
are
Kate, I really want
really,
to
Yep, go
I
ahead,
was just saying,
John.
I'm really going to foot stomp on the assume compromise thing too, because that is kind of a really, I mean, at the end of the day, zero trust is really a mindset change, right? It's really going from this very compliance based approach that most customers and most agencies and organizations kind of take as well, as long as we're compliant, we're good, right? And we've just seen time and time again that's just not the case. Compliance is the basics. That's like the ground level of what any security program should be built on. But this whole idea of assuming compromise, sometimes we've talked to some customers where bringing up assuming compromise to the security team, they kind of take offense to it, right? That's like, so you're saying we're not doing our job? And it's like, no, that's it's not what we're saying. It's really just that you need to, when it comes to adopting these kind of methodologies, it's really about assuming that there's adversary there, and our job as security team is to eradicate that persistence or that adversary as quickly as possible. So that's a a really important part of zero trust.
Definitely is. And I appreciate you putting some more emphasis on it. It really is a mindset change. And it really involves, I believe, a changing in the understanding of what are the ground stakes, what are the things that you have to have in place to start to move towards that zero trust framework, to be actually getting that value out of a zero trust network. And first and foremost is user trust. So if you're not doing two-factor authentication, you don't have good user auditing policies and authentication controls, as well as authorization controls, you should go back and go start there, because zero trust ain't going to help you none. You need to have those in place up front. And that's really important that you've already got those in place. The next thing that's a kind of a zero trust basic is being able to derive device trust. Do you have corporate antivirus? Do you have endpoint protection on the device that's connecting to it? Do you have control of that device's posture? And even cooler, do you have that control over time? And can you factor that in to that continuous authorization process? So do you have those two things in place? Are you logging it in your existing SIM? Do you have your Elastic or whatever you're using? Are you pulling that data together? And can that data be surfaced to the enforcement points? And I'm about to talk about what those mean, and really drive that continuous authorization from a data perspective, just like the NSA prescribes. So you need to have those pieces in place to bring them all together. And then we talk about what is it that we need from a perimeter perspective. But before we do, you got to pause and say, well, this sounds like not a small amount of work from an architecture perspective. And you're right. So you like, where's the why behind this? And John put this together. Really, he's got a great bird's eye view of the bigger challenges we're seeing with his security mandate inside of Elastic. But really, it's about the number of breaches. Heck, you can just watch the news and see the amount of breaches that are happening. A lot of it comes down to how IT and security is managing authorization to resources, and even more importantly, the tooling that they're using. Most SOCs and system IT around security are dealing with just so many different platforms that end up siloing their data in so many different ways. And those silos just makes really inefficient processes on something that's an ever-growing problem, that's security. And the way that Elastic really tries to think about it is just your security data. I need you to do this OODA loop where you can act, you can observe your data and your security posture, get the orientation to decide what next action you need to do. That OODA loop, Elastic really gravitates to that. And because we've integrated not only SIM functionality for security posture across different network elements, but also have the endpoint protection piece, those are integral when it comes to a zero trust network infrastructure. And really, when you bring those together, it's all about tearing down those silos that I just mentioned, not just from a data perspective, but all these different platforms have different alerting frameworks. You end up having different processes around those different alerting frameworks, and it just doesn't give you a cohesive security posture in a time that really matters. And zero trust is really attempting or at least Elastic, along with zero trust architecture, is trying to close those gaps and increase that visibility by tearing down those silos. And if we drill into what zero trust architectures actually are, it's great to kind of first start of what the heck are they going to replace is a good point. And first and foremost, it's the technical areas that you currently deploy a VPN for, protected assets. And if VPNs are already deployed, why the heck would I change it? What's the reasoning behind it? So historically, VPN access is implied trust. If you've got the VPN client, you've authorized to go to the VPN gateway, you can authenticate, and you got blanket access to that network segment, no matter what resources are running on it. And that in and of itself breaks zero trust, and that each asset needs to have its own defined policy around access and not be global as VPNs do. There's no active way to deauthorize folks unless you go into the VPN gateway interface and start deactivating accounts manually. And that just implies way too much trust. Again, going back to the slide before, the amount of breaches we see and the amount of lateral movement that's possible in this blanket architecture where VPNs can authenticate and then hit any resource behind that VIP is just inherently insecure and not really defensible, in our opinion, in modern architectures. So here comes the meat. Essentially, well, what's different? If I throw out my VPN, what the heck do I replace it with? And really, there's two different ways that you can implement it. Once you have, again, those table stakes down where you have multi-factor user authentication, you have your devices actually managed from a security posture perspective, you can leverage those two pieces along with Elastic or wherever you're aggregating your SIM data to surface that SIM data in an architecture that can either be implemented in two ways. The first is a software-defined perimeter. This is kind of the most advanced way. This is essentially creating two new pieces of technology that go between the end user and the app. The first is the Zero Network Controller. Controller itself decides based off of authentication and authorization, as well as an end user client. So a thick client is one of the necessities in an SDP zero trust architecture. But this end user client essentially sends a request to the controller, not to the end service, but to the controller, asking for one, do I have access? And two, where the heck is it? And that controller then looks up the user's credentials, authorizes the device based off of its security footprint and posture, and then sends back where is the endpoint resource located to the endpoint client that then connects. And because this connection happens in this hidden gateway, it is undosable. There is no way to attack it. It has no attack surface at all. The only way you find out about this controller is through the thick client handshake. And then this service has a drop all policy that only allows point-to-point traffic. So only authenticated IP addresses can authenticate through and even see this gateway to get to the service. So that's the gold level standard for implementing zero trust from a hardening perspective. And we'll see an example of this in just a second. Now, from a little less touch from an end user device perspective is the reverse proxy architecture. So you're trying to protect a service. Again, you have two components. You have a controller and a ZTNA gateway. But unlike the SDP architecture, in this architecture, the ZTNA gateway needs to be deployed alongside the protected application. The protected application then connects with an outbound connection to the gateway, and then the controller through the user authentication flow, usually HTTP, almost expressly HTTP, OAuth 2, SAML type flows. Through that flow, the controller can see the authorization, and then the source IP address that's successful knows the user's identity, can enforce the policy, and then tells the gateway controller to set up a point-to-point tunnel between the end user's device and the application. And in this flow, The burden is now on the app runners side for deployment, in that the ZTN gateway will be deployed per app. In the other architecture, the SDP architecture, there is a burden where you're deploying clients on the end user's device, but also the gateway itself and the gateway infrastructure can be a single or multi-instance. It can live divorced away from the applications and in the application infrastructure and be more of a global service. So where you'll have more burden deploying on the end user's perspective from an SDP architecture, you're going to have a burden on the operations side when you deploy a reverse proxy architecture, in that you're wrapping the applications themselves. So if you don't get anything out of this talk, there's really two main points in that zero trust architecture. To actually implement it, you need network controls around the protected services. Those protected services need to be controlled actively by a controller that's aware of not only the authentication and authorization of the user, but also the device's profile. And we'll see later that in the NSA's definition, they've asked to even go further and make continuous authorization factor into it. And we'll show some of the sort of controls that are in the Elastic Stack to enable those workflows in future implementations. So at a real high level, where do you wedge Elastic in those two different proxy architectures? Elastic really sits at the heart because Elastic's consuming consuming all of the data coming off the endpoints, the security protection of the profile of the device being authenticated, as well as the logs from the application and the access to the application from the server side. All of that data is being fed at Elastic. So you can see it here in the center of the stack, as well as pulling in, and very importantly, pulling in the logs from the controller itself, knowing who's getting authorized, what they're getting authorized to, and then what did they actually do after that authorizations? What URLs did they visit? Did they go to were they scripted and pulled out an enormous amount of data after authorization? Was there anomalous access patterns in the URLs that they went to? All of those things can be wired in because you're using Elastic and you're pulling in that data from not only just that controller, also the authentication system, and again, as well as the endpoint on the user's device that needs to be protected before they can access the service. In the Appgate implementation, Appgate is a big vendor of zero trust architectures. Here's where Elastic would sit essentially between the controller and the gateway. Again, we have a connector for Appgate when it comes to pulling in their controller and proxy logs, and those factor in well with our Okta connectors, our different types of Bro and Zeek sensor levels, as well as our endpoint sensor data. All of those sensor data can hook into Appgate's policy engine, and that policy engine can then implement both that initial authorization and authentication as NIST describes, but then it can go that last step and do the continuous monitoring and continuous evaluation of the connection like the NSA asked for. So who's doing it, right? Like that sounds all well and good. It sure is a heck of a lot of moving parts. Is there anybody who's actually implemented this stuff anywhere? And I'm super happy that some of my colleagues, and I've been able to be on the periphery of this project. There's a project out of the Air Force / DISA called Platform One. And Platform One is a DevSecOps software factory framework, and that they have built a complete environment wrapped inside of Kubernetes that is completely ready for a government authority to operate validation. So if you deploy in this DevSecOps Platform One framework, then your ATO comes with it. There is no authorization inside the DoD. You get complete reciprocation. And to build that software factory and to have that authorization out of the box, they had to implement zero trust in a way that's real. That's not just vaporware. And so they chose Appgate. and Elastic together to implement their zero trust framework. And you can see the link here. We'll pass some of these after the call, or maybe we can paste them in the chat, Faith. But the main one here that I want to point out is that Platform One has both implementations, both the reverse proxy implementation. So for folks who don't have a thick client, as well as for ones that are the software-defined perimeter implementation, the controller can do both. And it talks to Elastic for that continuous monitoring piece. To see this in action, and oh man, is this diagram busy. This is the network architecture at a high level, if you can believe that, of CNAP, that cloud network access point for the Air Force. So this is how they're doing east-west traffic coming in and out of IL2 to IL5 implementations on GovCloud. At the heart of it, you'll see Appgate sitting as a software-defined perimeter, but you'll also see Elastic as the aggregation point for every element in this architecture. And so this is a valid implementation. It's public today, so they are allowed to talk about it. It's not classified at this level. So I'd welcome folks to reach out. But the Platform One CNAP capability is kind of the gold standard when I've seen implementations of zero trust in the wild that are actually implemented and working. But excuse me, that's based off of Appgate's commercial technology. If you're an Elastic user, you're probably going, I'd love to kick something around in my lab that's free and open source. So I wanted to point out there are a couple of get you started sort of options. The oldest one out there, the first thing that I ever heard about that had some of the attributes of zero trust is a service that implemented the proxy level for a software-defined perimeter, only for SSH initially. They support some other protocols now, but back in the day, that was the main thing that you wanted to protect. If you were live on the internet, you didn't want your admin port being exposed. And they implemented single packet authorization, essentially a thick client way of hiding services. So they could hide their port 22 listening SSH service. And you can download this, give it kick tires, and you can slurp in its data straight into Elastic using a file beat. The last one I want to touch on, that's an open source implementation, a little bit more mature. It is not software-defined perimeter, though. It is only the reverse proxy-based implementation. So layer 7 needing Okta or some other SAML2 flows. So anything that's a web app, it's going to fit really well, being protected by Premium. Premium, completely open source, Apache 2, deploys really well, again, alongside FileBeat and MetricBeat to consume in its data. So to recap, where does Elastic sit? You're going to have a proxy that's aligned with a controller. Once you implement zero trust in your network, those are going to stream logs directly into Elastic, as well as for authorization, look to Elastic's data to make authorization decisions, as well as consume information from a SIM perspective, like endpoint data and sensor data as well. So central to your zero trust network, alongside your data layer, will be Elastic. And why is that? For folks that don't know, Elastic has an open detection framework that can drive those authorization deactivations. Essentially, when we see nefarious activity coming out of these streams, we have an alerting framework that I'll show you in just a minute, if we have time, through the demonstration portion of the session. But essentially, we're able to push events from Elastic's store into the controllers, or they can be pulled. And that way that a continuous authorization can be implemented, as well as the other things that matter when you're collecting this information. You don't, again, want to put it in a zero trust specific silo. We are adamant that having the data spread out in all these different silos just makes the job harder. So all of your monitoring and compliance data is also in there, as well as doing threat hunting. So the platform is search-based, it is very fast, and so you can do threat hunting on the same data store that you're using for your zero trust network evaluation. And then lastly, hunting and incident response workflows are fully implemented. So we have things like timeline investigations and case management, right there along with your SIM detections. And those are backed by more than just static old thresholds or just in IOC based alerts. We do have anomaly detection on time series data built into the platform as elastic machine learning, as well as supervised machine learning to do entity-based anomaly detection on things. So we do have that next level of protection. And once you have all that in place and you're having a little success, the boss don't believe you, and he needs a nice little infographic proving that your platform is actually doing what you're saying it's doing. Elastic has you covered there too. Elastic has a very robust dashboarding framework, as well as kind of a pixel perfect framework that we call Canvas, that can do really interesting graphics, as you can see here from a platform one perspective. They can do their metrics roll up for their bosses too, without ever leaving Kibana, the same interface that you're using to implement your zero trust data repositories. So enough with slideware. I'll pop over just real quick, show you some of the relevant pieces inside the Elastic stack when it comes to specifically zero trust. Again, Elastic's a very mature platform, lets you do a lot of different things with your data, not just security, but also systems monitoring use case up under observability, as well as just pure analytics by building your own dashboards and doing your own machine learning jobs. But when you're looking at Elastic through its security application, again, we have built-in endpoint protection. And one of the things I want to highlight when that protections do fire, they do send back a very detailed analysis back to, it's like I'm having a little demo fun here. I'll try to see if I can pull it back up in just a second. But they do send lots of metadata back to Elastic, and that metadata is then surfaced again from that zero trust network architecture perspective. It's essentially the signaling to deauthorize can be looped in from the endpoints themselves. And to manage all of that looping in, essentially Elastic has controls for all of your different endpoints now wrapped in a manager, to where you deploy the endpoint one time, it'll upgrade it, and you can configure it from a central location, never leaving your SIM application. So as you can see here, you can implement endpoint security. You've got some pretty advanced controls. You can put it in prevent or detect mode. You can customize what the end user actually sees when an alert does fire, when it does find a malicious binary. And then you can customize what sort of signaling it's signaling in to bring into that zero trust network decision. So we have really advanced ways of gathering information, as well as actually taking action on the information. So the detections themselves, when you create your own detections, as well as the detections that we ship with, Elastic ships with almost 540 detections out of the box, all aligned with MITRE ATT&CK, but you can create your own. So as your zero trust posture evolves, you're going to be able to encode any sort of behavior you want to affect that deauthorization event. And once you do that, you wire it up from the web API to push back and deauthorize either Appgate or whatever sort of proxy technology you're implementing for zero trust. So that's just a real quick sneak peek. I welcome anybody, if they want to go kick the tires, you can go over to cloud.elastic.co for our commercial, and then I'll show you a link in just a second. If you want to go over to our Glove Cloud instance and stand up a trial there, we welcome you too. So popping back to kill you guys a little bit longer with a few more slides before we wrap up, I just want to highlight some of the other reasons that the Air Force, as well as a lot of our DoD and IC partners, look to Elastic to help them with their zero trust implementation. A lot of it's the flexibility of the platform. So Elastic doesn't have to be one monolithic cluster. We can deploy in a federated way. We have geo-based technologies that'll let you fail over between data centers with cross-cluster replication. So we really kind of have your back when you try to deploy us at scale across a global org. And we don't do that alone. We've got tons of different partners on the ingest side. There's lots of commercial products that we partner with first as a top tier, and then just through APIs, as well as sitting on top of Elastic things like SOAR capabilities through SOC Prime and Swimlane, as well as pulling in commercial IOC feeds like Anomaly and the like. And then Elastic's used from a lot of different security implementations on the open source side. You ever heard of Security Onion or Wazoo? They're all based off of Elastic. So there's a really large ecosystem to draw from if you base your zero trust technology on Elastic platform. But I'll leave you with one of the kind of the burning things that actually happens when you have a little success in your SIEM. You keep adding more and more data to it. And as you add more and more data to it, if it's not optimized, it can cost you an arm and a leg, mostly if you're in the cloud. And Elastic's aware of that. We definitely have our own security data that can cost us 2 arms and a leg because we got a lot of clusters that we manage. We've developed technology that essentially lets us manage big, enormous data as it moves over time from a security perspective, which really matters in zero trust. And to do that really efficiently, we have a hot, warm, cold, frozen architecture, which lets data flow as it ages and you use it less into cheaper and cheaper and more efficient data usage stores, mostly if you're in architectures that are based on like Amazon and the like. As you get towards frozen, storage goes from NVMe on the hot side through to spinning disks into S3 on the frozen side, getting the least amount of cost for the most amount of data. And that'll help you unify operations. So when you bring zero trust and Elastic together, you'll get a lot of tools that'll collapse into one set. And that really has a big effect both on the operations on the architecture side of your security posture, as well as just having a unified tool. So you're not having as much alert fatigue. You can close tickets a little bit faster. So your metrics start to improve, and just all around your overall network posture and metrics can be not only improved, but then surfaced through our reporting. So to wrap up, zero trust really means you don't trust anything anymore. Network perimeters are a thing of the past. To do that, you got to log and verify every damn thing. And it's really important that you assume compromise, as John highlighted, that really the way it is today, that there's, even though you're past the corporate perimeter, it doesn't matter that all endpoints are hostile until proven uncompromised. If you're curious about how this stuff works, you want to talk to us more at length, we'd be happy to schedule a one-on-one demo, talk through more of your zero trust plans, give you some more insight into what's happening in Elastic Security and where we're going. If you go over to elastic.co/federal, there's a contact me request form and just a ton of information on the site itself, but feel free to fill in a contact me, and John or one of our colleagues will be reaching out to you pretty soon. So just wanted to say thanks, and I'll pause here. I don't know, Faith or John, if there was any questions that we wanted to answer towards the end here that came into chat.
Yeah, I had one question here that I'll read out, and I'll give a quick answer, and Kent, to see if you have some other smart things to say about it. So the question was, how close is a fleshed out continuous diagnostics and mitigation architecture, or CDM, to a zero trust architecture? And so I actually accidentally posted this, not publicly, so I just waited to respond. But my thing was, I think they're really complementary. So I think, CDM in general is kind of it's a good basics. It's the basis of what is zero trust, architecture or program can be built upon, right? Because the whole idea is it's about collecting all that telemetry, and especially with the new EDR kind of mandate being put out in the EO, and some of the new logging requirements being put out in the EO that came out from the administration not too long ago. It's a good start, right, as to kind of building. And that's why one of the things that I think the industry has kind of been a disservice to zero trust is, a lot of the vendors in the industry have kind of been like, well, hey, just send us all your money and we'll fix this problem for you with technology. And I really do think a lot of agencies and organizations have a lot of the building blocks kind of already there. It's just a matter of kind of putting some things together and putting the puzzle pieces together and changing methodologies of of their security teams to kind of have that assumption of compromise. But yeah, I think CDM is a great, kind of start that gets the U.S. government, on the path of where zero trust is supposed to take us. I don't know, Ken, do you have anything else you want to add to that?
Just to second it, in that CDM actually mandates that you have to collect at least some of those sources. Definitely around device trust, that wasn't mandated in previous iterations. So it kind of mandates that you're gathering some of those ground pillar data sources that you'll need to implement a good zero trust policy. So they're definitely complementary, as John said.
Yeah, and the thing too that Ken, as I'm a pure play, cyber guy, right? So like, when coming into Elastic and with some of the frozen tier searchable snapshot things that, that we've released, really, and when I first kind of learned about them, I was like, oh, I mean, that's kind of cool, right? But it's one of those things that it really comes down to being very impactful to the security community of, we saw with SolarWinds, fairly recently that, there's always been this number of this 30, 60, 90 days, of how long an adversary is able to live within our networks and be persistent. And now we had a very sophisticated adversary persisting for, at least a year, right? And, the horror stories of how long, nobody has that much telemetry, right? Because this wasn't affordable. It wasn't affordable. It was an untenable amount of money, even with Elastic, before we released our searchable snapshots and frozen tier, to be able to have that much data actionable, right? And there's those building blocks of building this kind of zero trust architecture of we need technology that is affordable and is actionable so that we can have data and logs and telemetry coming from endpoints and all our different devices on our network, so that we can look back and see, hey, there's something, another screw we need to tighten up in what we're trusting here. Being able to trust our vendors, the supply chain for how much has that been kind of compromised, right? It's nobody is able to keep that much telemetry around. So these are the things that that we're trying to just keep adding value to our paying customers and to any new customers, and even our free and open customers for that have access to a lot more capability than they did the last release. So that's one of the things I like to make sure that security people are thinking about, that problem of data retention, and it's just something that I think we've kind of knocked out of the park.
Yeah, definitely. I agree. The reception I've seen when I've shown new architecture diagrams where they factor in that long tail of data, where that long tail is now S3 frozen with much more minimal resources, it just allows folks to look at more data sources and to broaden their scope of what they can bring into their SIM, and start to look at data sources that they couldn't in the past, like DNS.
I think it makes zero trust affordable. Like, the real kind of idea of what zero trust should be isn't just it's how can we make zero trust an actual thing and not just a pipe dream, right? Yeah. Of a bunch of how do we get out of the science experiment? PhD. I didn't offend any PhDs in the audience, but like, how do we get out of that realm of the potentially possible into an actual implementation, into an implementation that can be actually deployed on enterprise networks, right? Yeah, that's where you have to get zero trust to.
And I kind of frame it as that Google's definition of zero trust is, you can do that today. Pretty straightforward, not too hard. The NSA's definition of zero trust, a little bit harder. You need that long tail of data. You need to have continuous authorization driven on that data. And so having a data store that's capable of doing that without breaking the bank, it's kind of the table stakes. So just reinforcing what John said, that being able to retain that data and actually make it actionable from a zero trust perspective is pretty unique to Elastic. And it's something that I hope folks will be aware of. John, did you see any more questions, man, or we can wrap up?
No, I think unless anybody has anything else, I didn't. Made a couple of questions about some administrative kind of things in the video and some partner questions, but nothing that we need to directly address here. So want to thank everybody for their time. And, as Ken said, we are happy to, I think some of the folks that were asking about for some partner questions, more than happy to, speak to, just reach out to contact us or reach out to our community team, and we can get, set you all up with the right teams to work with. Now one of the things I'm very interested in discussing with any kind of partners or integrators that are out there is, how we can work with you. This is not, there's not one vendor that can solve zero trust, right? This is very much going to be a solution. And, as a community, we need to have, it's a team. This zero trust is a team effort, right? It's going to take a couple, vendors, a couple open source projects, a couple, folks to all kind of get these things together. And so we're happy to, and would love to speak with anybody that wants to kind of partner or work with our Elastic technology when working with the community or working with our customers.
Yeah, I'll second that, John. I'm actively looking for SI partners. If you're out there listening, we definitely would like to engage to work together to help some of our federal customers and prospects as they start their zero trust journey. We're looking for folks who'd like to help us in the lab and the like. So please do reach out. Me personally, I'm actively looking for.